So just like with whole numbers and fractions, we can compare decimals. And remember, when you're comparing two numbers, you're determining which number is bigger or which number is smaller, okay? So steps to compare decimals, all right? If the whole numbers are the same, we just have to compare the decimal part. So if the whole numbers are the same, add zeros to the end of the decimals so that they have the same number of decimal places, and then compare the decimal parts as if they were whole numbers. Okay. Now, of course, if the whole numbers are different, compare the whole numbers. Okay. But in the situations I've given you here, the whole numbers are all going to match. Okay. Now, remember, when we're comparing numbers, we have to use inequality symbols. And there are technically four of them. We really only use two at this point. So I'm just going to show you the two that we use. We have less than and greater than. Now, to me, the less than symbol looks like a squished uppercase L. So it looks like an uppercase L where the top is kind of falling down a little bit. So I always think L less than. If it looks like a squished uppercase L, it stands for less than. And the way these work is the point of the inequality symbol always points towards the smaller number, and the open wide side of the inequality symbol always points towards the larger number. Okay? So for example 5, it just says insert a less than or greater than symbol so that the statement is true. Okay? So for part A, we have 6.126 and 6.216, okay? Well, technically, this is 6 and 126 thousandths compared to 6 and 216 thousandths, okay? And remember, if the denominators of fractions are the same, all we have to do is compare the numerators. So technically, what we're comparing is 126 thousandths to 216 thousandths. Well, which numerator is bigger? The 216 is bigger, so we would say, let me do this in red so it's really, really obvious. We would say 6.126 is less than 6.216. Now, according to these directions, what I tell you is this. As long as you have the same number of decimal places, that's equivalent to having a common denominator. Because we know if we have four decimal places and four decimal places, we would put those numbers over 1,000 or 10,000 in that case, 10,000 in that case. If we had five decimal places, we'd be putting those decimals over 100,000. So we would have common denominators. Just like in part A, we had three decimal places for each number. So we were putting that decimal portion over 1,000. So we had a common denominator. Okay. So just understand that with fractions, we can compare the numerators as long as the denominators are the same. With decimals, it's easier. We just add zeros to the end of the decimal so that we do have the same number of decimal places, which is equivalent to an LCD or a common denominator. And then you just compare the numerators. So right here, we have 1, 2, 3 decimal places, 1, 2, 3 decimal places. We can see the number in front of the decimals the same, so we just have to compare the decimals. So I'm really just comparing 126 to 216. We know 126 is less than 216. Okay? So let's look at part B. So in part B, we have 13.208 and 13.28. So technically what we're doing is we're comparing 13 and 208 thousandths to 13 and 28 hundredths. So if we're looking at 208 over 1,000 compared to 28 over 100, we can't compare right now because we don't technically have those common denominators. But if I had a zero at the end of this number, I'm not changing its value. Okay, after the decimal point, I could add zeros all day long and I'm not changing the value of the decimal. But I am creating a situation where now we have a common denominator. So by adding that zero, we're comparing 208 thousandths to 280 thousandths, okay? So by just adding a zero to the end of the number so that they both have 1, 2, 3, 1, 2, 3 decimal places, all we have to do is compare 208 to 280. Well, 208 is less than 280, so that tells me 13.208 is less than 13.28. Okay? One more. Now, we have to be really, really careful when we're comparing negative numbers because negative numbers work just a little bit differently, okay? Remember, when you're on the negative side of zero, so to the left of zero, the further away from zero you are, the smaller you are. The closer to zero, the bigger. So keep that in mind, okay? Now, for our first number, we have 209 ten thousandths. For the second number, we have 29 thousandths. So, like, what in the world's going on here? We don't have that idea of a common denominator. But it's as simple as adding a zero, okay? So if I add a zero, what I'm technically dealing with is 209 10,000ths compared to 290 10,000ths, okay? So by writing the numbers with that extra zero at the end, all we really have to do is compare 209 to 290. Well, 209 is less than 290. So, I was about to throw in the wrong inequality symbol. So 209 is less than 290, but remember, these are negative. I almost screwed myself up right there. So these are actually negative. So if I'm comparing negative 209 to negative 290, which number's bigger now? So kind of envision a number line. Well, we've got our zero right here. Let's say 209 is right here. That means 290 is way down here. So which number is actually bigger in this case? In this case, 209 being negative is actually bigger than negative 290. So we would write it like this. So negative 0.0209 is greater than negative 0.029. Okay. So I warned you about the negatives, then I almost forgot it myself. So just be really, really careful with those negatives. Okay. But that's how you compare decimals. Just make sure they have the same number of decimal places. That's the same thing as getting the same denominator, and then just compare the decimals at that point. Okay.